Okay, today's lesson we will study on strengths of acid and alkalis. Now, I want you to read your textbook later. I'll just go through with you with short notes, okay? Now, when we talk about strength, it's telling how strong is it or how weak is it. So under acid, you actually have two types. One is a strong acid and one is a weak acid. For alkali, strong alkali and weak alkali. So before you know what does strong and weak means, you need to know degree of dissociation, or you call it as ionization. You can use either one of this word. Actually, what does this means? It means the percentage or the fraction of molecules. These molecules that we are referring to, it can be acid or it can be the alkali molecules. So the percentage of these molecules break down completely, dissociate completely in water. Meaning, some acids alkali dissociate 100%, but some only 1%. So let me explain to you with examples, okay? Now let's say this is a beaker, and two different type of acid. Now, hydrochloric acid, let's say I'm going to take 100 particles of hydrochloric acid, I'm going to dissolve it in water. What will happen is the water will break, will dissociate, or you use the word ionize. You don't use the word break. You use the word either it dissociate or ionize this hydrochloric acid into hydrogen ion and chloride ion. Since here 100 particles, when it breaks, when it dissociates, it completely dissociates into 100 particles of hydrogen ions and 100 particles of chloride ion. Don't wrongly think it's 50-50. Yeah? It's exactly 100, exactly 100. And once it has already ionized, it doesn't go back to this. Once it ionized, it doesn't go back here. It's just this arrow. Okay? Now this one you call it as completely ionized or dissociate. Whereas there are some kind of acid, like for example, the name of this acid is ethanoic acid. What happens is when I dissolve it in water, supposed to be 100 particles change to H plus and 100 particles of this ion. But what happens is some kind of acid, they are too weak that the water cannot break it completely. So what happened? Only few it will break. So when I dissolve this, only 10 particles of hydrogen ions are formed and 10 particles of ethanoic ion form. The remaining 90 will exist as molecule. This is an acid is actually a molecule. An acid or an alkali is actually a molecule. It becomes ion when dissolved in water. So this one you call it as partially ionized or partially dissociate, because supposed to be 100 become 100 of this and 100 of this, but it doesn't happen because they are too weak. The water cannot break it completely. So 90% it remains as still as acid molecule. So imagine if it remain as acid molecule, it doesn't show a very good acidic property. The acidic property will be very weak because only got 10 particles here. But whereas this one will show a very strong acidic properties because there's 100 hydrogen ions. Okay, so I repeat again here. For strength of acid, there's strong and weak. Strong means it will dissociate completely. If here I put 1,000,000 of particles, 1,000,000 of hydrogen ion will form, 1,000,000 of chloride ions will form. But certain kind of weak acid, when I dissolve in water, only maybe 10% will form, or only 1% will form into hydrogen ion. The remaining 99% still remain as molecule. And if it is molecule, it cannot show the acidic property. Okay, it must be in terms of hydrogen ion. So you call this as partially ionized. Now you also need to take note on the arrow. This arrow shows that completely ionized. This is half arrow. One towards on the top, one towards the bottom. Okay, this half arrow shows that once it forms hydrogen ion, it can go back to this. Alright? Okay, next. you need to know the definition of strong acid and weak acid. So strong acid, we already know that it 100% ionizes. Must know the definition, yeah? You write this in your textbook. In the beginning of the lesson, you have learned what is the definition of an acid. Actually, what's the definition of an acid? Acid is a chemical substance that dissociates into hydrogen ion when dissolved in water. Now, I'm just using the same definition. In your textbook, you may see the definition changes. So you may feel like, I have to memorize few definition. No. If you follow the definition that I am using, you notice that I'm using the same definition, just I add in words. I repeat again. Acid is a chemical substance that dissociates into hydrogen ion when dissolved in water. That's the first definition you learn in the very first part of this chapter, in the very first video. Now, if I say strong acid, it means a strong acid is a chemical substance that dissociates completely, I added this word, into hydrogen ion when dissolved in water. So the same definition, just you're putting this word. Okay? To produce, I did not complete, to produce higher concentration of hydrogen ions. I will explain to you this shortly. To produce higher concentration of hydrogen ions. So I'm adding this one. So only two part I added in your existing definition. Now weak acid will be, is a chemical substance that dissociate partially into hydrogen ion when dissolved in water to produce lower concentration of hydrogen ions. I'll explain all about this shortly. Okay, so this one I added. So you must know the definition because in structures question, you have to use the definition to explain. I will give you the example of structure question in your upcoming assignments. Now, the next thing you need to know is the examples of strong acid and weak acid. There's a lot of examples for weak acid, but I only want you to focus on these 5. No need to read too much. Study smart, okay? So example of strong acid, only 3. Hydrochloric acid, sulfuric acid, nitric acid. Example of weak acid is, you call this as ethanoic acid. Okay? Ethanoic acid. These 3 I know you have already learned in your form 3. This is ethanoic acid and phosphoric acid. Now, some students may wrongly think phosphoric acid falls under here. No, strong acid only got 3. Weak acid, just memorize 2 is enough. There's a lot more of weak acid. Like all the acid in fruits and vegetables fall under weak acid. But you don't need to know about that. You only know this 2. Okay? Okay. Now, just now you learned this word higher concentration, lower concentration, right? What does it mean? So now we are going to study the relationship between the strength of acid with pH. Strong acid, it means it ionizes completely, right? So if let's say I put 100 molecules of acid, this entire 100 molecules will change into 100% of hydrogen ion. Okay. If it is a weak acid, it only ionizes partially. So meaning if I put 100 molecules, maybe only 8 or 10 molecules will become hydrogen ion. The remaining still exists as molecule. So when I compare with this, which one has more number of hydrogen ion? This one, right? Since this one has more number of hydrogen ion, a strong acid will produce a higher concentration of hydrogen ions, whereas a weak acid produces a lower concentration of hydrogen ion. That is what is in the definition. You see, is to produce higher concentration. This one is to produce a lower concentration of hydrogen ion. Okay, now how does this affect the pH value? You have learned in your yesterday's lesson, the higher the concentration of hydrogen ions, the lower the pH value, meaning it's more acidic. And the lower the concentration of hydrogen ions, the higher the pH value, which means is less acidic. Okay, can? Okay. Now, the last part you have to learn about the strength of acid is the relationship between the strength of acid with the rate of reaction. or properties, meaning you have already learned that acid will react. You have learned this in your form 2. You go back your form 2 syllabus, you have learned that when an acid react with a metal, it will form hydrogen gas and it will form a salt. Don't worry, you will learn this in your next topic, okay? But this is your basic lah. Okay, then you have also learned when acid react with metal carbonate, it will form salt, water and carbon dioxide gas. It comes from here, okay, and it will form carbon dioxide gas. So all these are type of reaction. Now if it is a very strong acid, the rate of the reaction will be very high, meaning the reaction will be very fast. If I use a weak acid, the rate of reaction will be low, meaning these reactions will happen too slow. That's all, okay? Now I just want to show you this table. This is to tell you the differences between hydrochloric acid and ethanoic acid. You see, the concentration is the same. But tell me which one is strong acid, which one is weak acid. This one is strong acid. This is a weak acid. So although the concentration is the same, who will actually produce more number of hydrogen ion? This one, right? Because 100% will completely change to H+. But this one only maybe 1%. The remaining 99% still exists as a molecule. So when I test it with universal indicator, it will give you a very red color because it's trying to show it's very acidic. Why very acidic? Because higher concentration of hydrogen ion produced. Whereas this one, it's between orange red, meaning it's trying to show it's a weak acid because lesser concentration of hydrogen ion produced. Now when I react with metal, you will produce hydrogen gas. Hydrogen gas evolves vigorously, meaning very fast the hydrogen gas produced. You can see a lot of bubbles within few seconds, meaning the rate of reaction here is very fast. But over here, the hydrogen gas evolves slowly. Why? Because the rate of reaction is too slow. Why? Because only got less hydrogen ion. The same goes to when it reacts with calcium carbonate. The carbon dioxide vigorously, here slowly. If I test it with electrical conductivity, here it lights up brightly. Why? Because got a lot of free moving hydrogen ions. But here got a lot of molecules and very less hydrogen ions. So it is dimly. So what's your conclusion? HCl is a strong acid that produces higher concentration of hydrogen ions when dissolved in water. Don't forget the term when dissolved in water, because if you did not write when dissolved in water, you must understand without water, no acid can be an acid. Okay? And this one, ethanoic acid, is an example of weak acid because it produces a low concentration of hydrogen ions when dissolved in water. So all the reaction will be very slow. Here all the reaction will be very fast. Okay, so that is about the strength of acid. The next video I'll explain to you for alkaline solution, which is exactly the same.